when the keep alives kick in, or a layer 2 protocol pulls it down in that case. But BFD can work out certainly to your advantage there. Once again, another part of BFD is you have the ability to specify minimum thresholds, where you could basically say that what are the minimal thresholds of that you want to operate at. And from there, it's continuously negotiating what those timers are going to be that the routers can support. So it's not like a static number, and you basically specify you're defining, enabling this on a BGP peer group for external peers or whatnot. You can specify the minimal thresholds that you want to operate at, and the protocol will negotiate and continually negotiate what timers you can safely operate at. And then once the failure is detected, it could then pull that session down. So, typically with BGP neighbors, you can already by default specify keep alives and what interval on a per neighbor basis. With this, you could probably do the similar here, but it works out on exchange LAN where you have different participants. People have different thresholds of what they can operate on the routers. People have different kind of routing engines and route processors. So you can set just a threshold, and then it'll negotiate higher as configured. Another one, another instance where you can run BFD is in the MPLS space, specific with LDP. You can use this for essentially path verification, although you can't really use it to actually reroute or trigger any kind of action in the router, because with LDP you're relying upon your their IGP to tell you where to route. But what it can do is it can at least provide some sort of liveliness detection to say for a particular FEC that has gone down, and notify you that, at least in syslog and whatnot. So it does provide you ability to see when an LDP-based path is no longer reachable. This is pretty useful in certainly in LDP networks, especially if you've run into issues with LDP blackholing. This can typically pick it up for you. Another capability with LDP is that it allows you to do ECMP. So within your network, you can have a path branch out to multiple paths across the network. And with BFD here, I can use a combination of LSP ping and traceroute to discover the entire ECMP tree to the destination. And it could create a BFD session for each individual path and then transmit the packets along. And you can bring up the sessions there. And a quick little picture of that is shown here, where in this case you have two individual BFD sessions on two diverse paths that have equal cost. The next one covers MPLS with RSVP TE LSPs. In this case, you can use BFD on an individual RSVP LSP that's established. And one of the things that you can do here is, because the LSP takes one single path, is you can actually enable BFD on a given LSP, and when the LSP fails, you can actually take some actions at that point. So let's say you have a given destination router, you have an LSP2, you could build multiple paths there and enable BFD in each individual one, and you can say, well, if BFD is running in one LSP across the network, something fails, well then you can trigger that the standby LSP will take over, rather than relying upon something else happening in the network, such as getting RSVP message back at the head end saying that the path is gone, or waiting for CSPF to run and take a different path in this case. So it really gives you a nice little, if you have a given destination, you want to verify that you can talk to it, you can use BFD to really trigger and detect if anything's broken on the path. Another capability, although I haven't really seen this one deployed, is that you could use BFD in the point-to-multipoint LSP scenario. And the only reason, perhaps why anyone would want to do this is, point-to-multipoint LSPs are typically used for distributing video content and things like that across the network. And in those cases, you're already having some sort of additional constraints on you, such as rapid reconvergence, so you've got fast reroute enabled, bandwidth reservation sometimes, and even explicit routing to stay on SRLG-free paths. So in a case where you're probably doing point-to-multipoint, there's typically a reason for it. You're carrying something that's somewhat important. BFD can be useful here to detect a failure as well. Another case, I haven't seen this deployed, I'm not sure who actually, if anyone has this implemented, is that you can actually run it in the pseudo-wire space. So when you're building either, Ethernet layer 2 VPNs, layer 2 circuit pseudo-wires from two different endpoints, you can even use BFD in this space to actually verify that connectivity works end-to-end. Well, obviously there's no such thing as a free lunch, and there are some caveats to actually using BFD. And the two main ones, at least that I've seen, is that it can have high resource demands on the router, depending on what kind of router you have out there. and what timers you're using, as well as it doesn't really have any visibility into layer 2 protocols, specifically bundling protocols, so Ethernet bundles, things like that. To go on the first one, the resource demands, obviously you're running BFD, you're running this instance on either a line card or a raw processor. It's firing off pretty frequently. The more sessions you're going to add, the more it's going to utilize the resources on our given router, right? Not only that, but each individual vendor can put their own stipulation when you create a BFD on an interface where they'll put a minimum transmit-receive interval where you may have it enabled. You may want to select to use lower timers, but the software has been essentially instructed to say, no, you're doing it on a bundle interface. Your minimum interval has to be at least 250 milliseconds. So even though you want to run it lower, you may not be able to just because the vendors put some sort of control into it in that case. Another thing is, where you're going to run BFD, it runs, you can run a distributed model, but depending on the protocol, it may run off the route processor just because it's not directly associated with any physical adjacency. So if you're running it on IBGP sessions or you're doing it on an LSP, it's got to come from a centralized location on a router, which means it's ending up on the route processor in the end anyways. So, the route processor is doing other things, could be doing BGP, could a whole other sort of options. That it's something that you have to be concerned about. And the main thing here is that you need to test your platform before you do anything here. Whatever you're going to deploy, you definitely want to stress it and put some load onto it to see at least if you're able to break a BFD adjacency in this case. And there's lots of ways you could do this, but definitely want to stress that you should stress test your box. There's a lot of ways you can do this. You can execute a lot of regex commands on the route processor itself. You could try to simulate a denial of service attack, such as if you want to see what a line card can handle, well, make the line card CPU work a little bit harder, send packets that TTL expire on it, send options, do whatever you can, right? Because when you actually end up deploying this, you're going to see a lot of different things in the wild that you just may have not thought would come up, and you definitely don't want BFD to be there pulling things down accidentally in production. Regarding what kind of values are safe to try, one popular one that I hear is 300 milliseconds minimum transmit receive intervals with a multiplier of 3, which gets you just barely below a second, so it's technically sub-second in that case. And from what I've seen of vendor documentation, they seem to recommend that value as well in some of them. But once again, you should probably try some particular value that you're safe with, and then you can work down from there. In any event, it's still better than what the alternatives are, which is relying on your existing timers or even cranking down your existing timers, where you have to maintain that across your network. And then if you have different kinds of equipment out there, different route processors, and you have to set different values for different boxes. It's still an improvement than what you may have today. The other caveat that I mentioned was BFD and link bundling. And one of the things here that's kind of an issue is that if you do have multiple links in a layer 2 bundle, BFD works at layer 3 generally when you're building it across, let's say, an IGP adjacency. It doesn't know that there's 4 links, 10 links, or whatever's really underneath. So when those BFD sends out its datagrams, it's typically going to treat it like it would any other packet that's going across the link, right? So layer 2 hash is going to say, okay, I've got 4 interfaces. This packet's going out on number 2, for example. It's not going out through all 4, although there's some implementations reportedly that can do this, but it's only going to go out through one, and the response is only going to come off through another interface in that case. And, well, the problem with that is, well, actually, in that case, what would happen is, let's say it's going out on the interface that just happened to have gone down. Well, do you want to declare the entire bundle as down at that point just because one individual member link failed? You probably don't want to do that. So it can really bite you in that scenario. A lot of it is dependent on the BFD implementation on the router. For example, you have a layer 2 link bundle go down. By the time it sends out the next datagram, it could have already rehashed the layer 2 bundle and sent it out on a different interface. So it can perhaps work around the inefficiencies of the way that the layer 2 hash bundle, the fact that BFD lacks the ability to look inside of layer 2 bundle. Back on this one, obviously, it is somewhat of a showstopper given that layer 2 link bundling is pretty popular with n by 10 gig links. 40 gig is there, but 100 gig is still far along the way. So, the fact that this doesn't really work all that well in layer 2 bundles can be a bit of a showstopper. What would be kind of neat would be if you had the capability for BFD to fork on individual member interfaces and operate on every single one and then send it back. But of course, if you were to do that, then you have additional BFD sessions to have to worry about, and then that's going to impact your scaling as well. On the conclusion, so a few different notes here. Routers still have faults in the forwarding plane, and where you can actually have a fault, and IGP can remain up, but the line cards just do not forward. And I know in 2008 there were at least two large events that did happen where routers just IGP adjacencies remained up, but packets were just not forwarding through the boxes, and it could take anywhere from minutes or hours in some cases for people to really realize what was going on. The default hello and keep alive timers that some protocols have today, they're still too high. A lot of people don't adjust them, and it's unfortunate, but a lot of people don't know all the knobs and the tweaks or have the time to really experiment and see what works. BFD kind of says it's a little bit of a shortcut to say, well, don't bother playing with them. Just go to this. It's a standardized method. The implementation is pretty much well supported on most vendors today. Just you don't have to worry about tweaking it. Just try this as an option. On the issue of the layer 2 link bundling issues, it'd be great if there was a way that you can actually get BFD to work in this environment, given that N by 10 gig is probably going to be with us for still quite some time. N by 40 gig, if you're doing 768 and whatnot, you're still going to have the same problem there too. The other issue is definitely always remember to stress test your equipment. Not one size fits all when it comes to some of these configurations. Regarding just polling a lot of different operators who do run BFD today, it seems that of all the ones that I've listed, the only two that really are popular are using it in the eBGP space and using it for IGP adjacencies. But outside of that, I haven't really seen anybody who's actually used it in the MPLS environment. Some minimal stuff with OANM to use it for LDP paths to really notify when black holing or things like that occur. But it seems the eBGP and IGP adjacencies are probably, like, if you're going to play with it, that's probably the first place to start. And it seems to have worked okay in some people's networks today. But there's a lot of people pairing here. There's a lot of people exchanges. It'd be interesting to see if people said, hey, we went through this whole MD5 thing, and that was a pretty large group effort that a lot of people went through. It'd be interesting to see if a lot of people would go through kind of a similar support of, hey, let's start enabling BFD on the IXs and see how things work out in a widespread manner, at least to find out what vendors it works out well with and what numbers, because there's just not a lot of data out there supporting if people are running this today or how well it's been working for them. And that's pretty much about it. I don't know if there's any questions or comments.